Welcome to the session on forces and friction. The objectives for this session are to understand friction and the coefficient of friction and use F less than or equal to mu times R. Friction is a force which opposes motion between two rough surfaces. Friction takes place when the two surfaces move relative to one another or when there is a tendency for them to move relative to each other. Let's take a look at a stationary block. Notice that in the diagram, the block has mass m. There is no horizontal force being applied. We have a reactionary force and the weight m times g, the force of gravity. Since no horizontal force is being applied, there is no tendency for the block to move. Therefore, no frictional force is acting on the block. Let's take a look at another stationary block. This time, horizontal force is being applied. So there is a tendency for the block to move. The block doesn't move, however, because the frictional force is equal and opposite to the force being applied. So in the diagram, we have that F equals T. Now let's take a look at the moving block. Horizontal force is being applied, and the frictional force increases to prevent the block from moving. So here's our block again, mass m. Here's the reactionary force and the weight, mg. This time we have a force being applied horizontally, and the direction of motion is towards the right. So T is being applied, the frictional force is resisting, but it's not enough to prevent the block from moving. So the block will move when the magnitude of the applied force exceeds a limiting or maximum value, F max. The frictional force will remain constant at its limiting value while the block is moving. Let's now take a look at this limiting value of friction. This value is dependent on the normal reaction R between the two surfaces in contact, and the roughness of the two surfaces which are in contact. The roughness is measured using the coefficient of friction mu. Rougher surfaces implies a larger mu, or a larger value of mu. Smooth surfaces imply mu equals 0. The maximum or limiting value of the friction between two surfaces is F max equals mu times R, where mu is the coefficient of friction, and R, of course, is the normal reaction between the two surfaces. Let's now take a look at an example. A block of mass 5 kilograms is pulled along a rough horizontal surface by a horizontal force of magnitude 10 newtons. The coefficient of friction between the body and the surface is 1/14. We are required to calculate the magnitude of F and the value of the acceleration. Pause the video and have a go. Press play when you're ready to view the solutions. So let's solve this. Here's our mass 5 kilograms. Here's the reactionary force and the force of gravity, or the weight, 5g newtons, and the force being applied, which is of magnitude 10 newtons. the coefficient of friction here. So we have F equals 1 over 14 times R. And we're required to find the magnitude of F for part A and the value of the acceleration for part B. So let's begin by calculating the magnitude of F. If we resolve horizontally, we have that R equals 5g. Now we also know that F equals mu times R. So we have F equals mu, which is 1 over 14, times R, which is equal to 5g. And since g equals 9.8, we can plug that in to our equation to give us F equals 3.5 newtons. Now let's take a look at part B. We're required to calculate the value of the acceleration. So let's solve this. Now from part A, we know that F equals 3.5 newtons. Therefore, if we resolve horizontally and use the equation of motion, F equals ma, we have 10 minus F, which is the force acting in the direction of motion, equals m times the acceleration. And substituting in F equals 3.5 and mass equal to 5, and tidying up gives us that A equals 1.3 meters per second squared. Now let's take a look at another example. This time we're looking at slopes. A particle of mass 0.5 kilograms is sliding down a rough slope that is inclined at 30 degrees to the horizontal. The acceleration of the particle is 0.25 meters per second squared. Find the coefficient of friction mu between the particle and the slope. Pause the video and have a go. Press play when you're ready to view the solution. So let's solve this. We have our mass, which is 0.5 kilograms. Our slope is inclined at 30 degrees. The acceleration down the slope is 0.25 meters per second squared. And we're required to find the friction, or the coefficient of friction, mu. Now, if we resolve perpendicular to the slope, we have R equals 0.5 g times cos 30 degrees. And this implies R equals 4.243 ... We've here, of course, substituted g equals 9.8 into our expression for R, or our equation for R. Now, if we use the equation of motion, F equals ma, and we resolve parallel to the slope, we have 0.5 g sine 30 minus mu r equals mass times acceleration. The mass is 0.5, and of course the acceleration is 0.25. So substituting in the various parts, so g equals 9.8 is substituted here. Sine 30 is also substituted in. Sine 30 equals 0.5, giving us 2.45. The value of r has just been calculated, and we can plug that in. 0.5 goes here, and the value of the acceleration goes here. And we can now solve for mu. And rearranging this equation gives us that mu equals 0.548 to 3 significant figures. Now let's have a go at another example. A box of mass 5 kilograms is being pulled along a rough horizontal plane by a force P that acts at an angle of 45 degrees to the horizontal. The coefficient of friction between the box and the plane is 0.1. Given that the box accelerates at 0.3 meters per second squared, find the value of P. So here's our mass, 5 kilograms. And here's our force P acting at an angle of 45 degrees. Our coefficient of friction is 0.1. And our acceleration is 0.3 meters per second squared. And we're required to find the value of P. So let's solve this. If we resolve vertically, taking the forces above the x-axis, we have r plus p sine 45 degrees, and the forces below the x-axis are 5g only. Remember, this is the weight of the box. So we have r plus p sine 45 degrees equals 5g. And so now we can plug in sine 45 equals 1 over root 2 and g equals 9.8. So sine 45 degrees goes here, and g plugged in here to give us this expression, r plus p over root 2 equals 49. Now let's use the equation of motion, F equals ma, and resolve horizontally. So we have in the direction to the left, P cos 45 degrees minus 0.1 r equals mass, which is 5, times acceleration, which is 0.3. Plugging in cos 45 degrees equals 1 over root 2. And then multiplying this equation through by 10 will give us a coefficient of 1 for r. This will allow us to use simultaneous linear equations and solve easily. Giving us this expression here. So now we have two equations, 1 and 2 as highlighted, and we can now solve for r and p. So adding the two equations as shown, gives us 11p over root 2 equals 64. And this will now allow us to solve for p. So p equals 8.23 newtons to 3 significant figures. This brings us to the end of this session. If you have understood its contents, you should be able to understand friction and the coefficient of friction, and use F less than or equal to mu times R. Thank you very much for listening. To understand this topic in greater depth, do attempt the exercises in your textbook related to this topic.